This is Knowledge Engineering with Semantic Web Technologies. This is the third part of the first lecture, Knowledge Engineering and the Web of Data. In this part of the lecture, we want to talk about understanding content on the web. The web, as you might remember from the first two parts of these lectures, has gone through several changes. So in the first part of the history of the web, it was the internet from the 1960s to the 1980s, late 1980s, when you had the time of the so-called computer-centered processing, and the access of information was rather difficult and was only for experts. In the second phase, the web of documents, it was the web as we know it. So the document now was on the focus in the web, and it was easy to access simply because you had this graphical user interface, the browser, which enables you to access the information rather easily. And the third generation here is the so-called web of data, or the semantic web. So here the data is in the center of the processing. So the web of data is nothing else but a so-called upgrade of the web of documents, and the web is somehow seen or regarded as a huge decentralized database or knowledge base of machine accessible data. So the vision of this web of data is rather old. So already in 1998, here Tim Berners-Lee stated when he first proposed the so-called semantic web that the web of human readable documents is being merged with the web of machine understandable data. So here, notice it's machine understandable, so it means not only it's machine readable, the data can be understood by machines, which means it can be interpreted correctly. And then, of course, the potential of the mixture of humans and machines working together and communication through the web could be immense. So, to enable this understanding of data in the web, we have a precondition. It means the content of the data on the web must be read and interpreted correctly. It means understood by machines. To do this, usually you have two different approaches. So one approach we all know, it's the approach that, for example, search engines do. So they do usually so-called natural language processing. So technologies of traditional information retrieval, and they try to understand based on statistics, based on NLP, linguistics and stuff like that. They try to understand the content or to learn the content with the help of statistical models and machine learning from the message you see, from the information you see. Another approach could be not to convey the meaning, the semantics in an implicit way as it is done right now in the documents in the web, but to add explicit semantic information to these documents. And this is the way of the semantic web. So in semantic web technologies, natural language, so the natural language web content is explicitly annotated with so-called semantic metadata. And this semantic metadata encodes the meaning of the content, and it can be read and interpreted correctly by machines. And in this lecture, we want to learn how we do this, how we really correctly annotate natural language content, for example, with explicit semantic annotation. Okay, let's get back to an example. How should this mean? How should this work? So to understand content on the web, what is necessary? And how could we interpret, for example, this picture? And again, also, you have this message in the picture which says, Pluto never forget, 1930 to 2006. Okay, first thing to do, you have to interpret somehow the text you see here. So the problem here is the text Pluto might be ambiguous simply because it's natural language text. So what does it mean? Okay, it could be, on the one hand, of course, a Disney cartoon character. Is it really that? Or on the other hand, it could be the Roman god of the underworld. It could also be the name of a song of the Icelandic artist Björk. Or it could be a ship, the HMS Pluto. Yeah, we all know it's the dwarf planet. It's Pluto, the dwarf planet, simply because we know that because of the picture. because of the picture, the interpretation for a human was easy. If you only have the text message, Pluto never forget, and then these 2 years, 1930 to 2006, interpretation becomes much more complicated. So the first thing you have to do when you interpret a message from natural languages, you have to disambiguate linguistic ambiguities. So now we have fixed that this Pluto is a dwarf planet. We do not understand Pluto. We have fixed it. Okay, it's a dwarf planet, but what does it mean? What is a dwarf planet? So what you do then is somehow you must explicitly define the meaning of this content. So we have Pluto, which means, or which refers to a so-called entity, Pluto. But what is Pluto? Pluto is a planet or a dwarf planet. We know that. So we can say, okay, the entity Pluto belongs to a class dwarf planet. And what is a dwarf planet, you might ask now? Okay, a dwarf planet is some sort of a special kind of planet. Of course, it's a small planet, so therefore the class of dwarf planets is a subclass of the class of planets. And in that way, of course, you could, for example, explain what Pluto is. But of course, a simple class hierarchy is not sufficient to completely understand the meaning of that. So to understand the meaning of a class, so what is a class? You have to define properties of a class. So usually entities which belong to a class share certain kind of properties. So therefore you also have to define the properties. So how does Pluto relate to other objects, to other knowledge? And this in the end defines the meaning or the semantics. So what else do we have? So for example, we know that Pluto is a natural object, for example, or we say Pluto is an astronomical object discovered in 1930, it's a celestial body, or it belongs to a class which is called minor planets to be visited by spacecraft, or already visited now. So the point is, if we know if this last class here, minor planets to be visited by spacecraft, is a subclass of dwarf planets, and we know that dwarf planet is a subclass of planet, we can deduce new knowledge, implicit knowledge, hidden knowledge, from this explicitly available knowledge. It means with the help of so-called logical inference, we can of course also deduce that Pluto is a dwarf planet, simply because we know it belongs to the classes here on the right side, and we know that one of the classes on the right side is a subclass of this dwarf planet. Moreover, we can also say that Pluto must be some kind of a planet, simply because we know it's a dwarf planet, and dwarf planet is a subclass of planet. So therefore, we can deduce that Pluto is also kind of a planet, is in the class planet. So class hierarchies, for example, here enable also already logical inference. So I can deduce new knowledge, hidden knowledge, implicitly available knowledge from the explicitly available knowledge. That's quite nice. Okay, on the other hand, of course, each class is described by its properties and its attributes. So for example, Pluto is a planet, and usually planet has a name. So you have a property which is called name, which gives each planet, which forms the domain of this property, a range, which is a string in that case of a name. Or the planet has a radius usually, and the radius usually is expressed in the range as an integer number. Or also it might have the property discovered, which means the date when this planet has been discovered by humans. So this means the discovery date, of course, it's given as a date. And of course, if it has been discovered and the discovery has been recorded, then there must be a person, for example, who has discovered this planet. So we have a property called discoverer, which has the range person. And with this information again, we can explain what Pluto is, what a planet is. So for example, for Pluto, the planet name would be the string Pluto. Or for example, the discovery date of Pluto was in the 1930s, so this would be 1930, for example. And with this data, with these specific properties, we describe what the entity Pluto really means. So, in the end, if each single piece of written information is given an explicit meaning, we create a so-called semantic web from this web of data. So the meaning of information, of semantics in the semantic web is made explicit. And this is done with the help of so-called ontologies, so by formal, structured and standardized knowledge representation. And in this lecture, we will talk a lot about knowledge representation and ontologies. So if you provide explicit information about the semantics, then it will be possible to process the meaning of information automatically, which is rather nice, because then machines are able to understand this meaning automatically, to a certain extent, of course. And then, of course, it would also be able to relate and to integrate heterogeneous data in an automatic way and to deduce implicit, it means not evident information from existing or evident information in an automated way. So there are logical rules, deduction rules, inference rules, which you can apply to deduce this not explicit knowledge, this implicit knowledge. So in the end, this kind of semantic web will form a global database that contains a universal network of semantic propositions. So it's not only data, it's really propositions. And the nice thing is, with the help of this knowledge that is here in this global database, you can deduce previously not known, implicit, already available knowledge. And so you can generate new knowledge from it. And this, of course, is a very nice thing. And this should give really great opportunities. So the semantic web has already been introduced more than 10 years ago. So there was, for example, in popular scientific magazine, Scientific American, an article about the semantic web in 2001 already. And there was a rather short and brief definition, of course, in a popular scientific way. The semantic web is an extension of the current web in which information is given well-defined meaning. So as far it, of course, it's the same like our definition. And it's better enabling computers and people to work together in cooperation. So this is the intention of this work to build the semantic web. So in the next part of the lecture, we will go a little bit into detail, and I want to show you first the technologies which are involved to enable a semantic web. And we will have a look in this so-called semantic web technology stack.